Hello, welcome to session number 2 on exercise 5A. Okay, so in this particular session, we'll be completing the problems which we have not done earlier in session number 1. Okay, so let us go to question number 16 from exercise 5A. Okay, so as we can see, there are two things given to us. Tan alpha is equal to m upon m plus 1. Tan beta is equal to 1 upon 2m plus 1. Okay, then what is the value of alpha plus beta? They're asking. Okay, so see, we know this formula tan alpha plus beta. We cannot take a tan alpha minus beta formula because we require the value of alpha plus beta. Okay, so tan alpha plus tan beta 1 minus tan alpha into beta. Okay, so that is equal to m upon m plus 1 plus 1 upon 2m plus 1 in upon the whole upon 1 minus m upon m plus 1 into 1 upon 2m plus 1. So what we can do is we can take LCM over here in the numerator as well as denominator. So this is m into 2m plus 1 plus 1 into m plus 1. Okay. Upon m plus 1 into 2m plus 1. Fine. The whole upon m plus 1 to m plus 1 minus m minus m, sorry, upon m plus 1 to m plus 1. Right. So some cancellations after LCM. Now we'll simplify this. Okay. So 2m square plus m, that is 2m. 2m square plus 2m plus 1 upon 2m square 2m plus m, that is 3m minus 1, and then this minus m. So this is equal to 2m square plus m plus 1 upon 2m square plus m plus 1. Okay. Yeah. So tan theta is equal to this 1. Therefore, theta is equal to 45 degrees. If your teacher is asking you to convert it into radians multiplied by pi by 180. Fine. So this is what the answer is. Okay. Okay. So let us go to the next problem. I suppose I should take question number uh, 17 right now. Question 17. Okay. In triangle ABC, A is perpendicular to BC. Okay. The foot of the perpendicular from A to BC is D. So we'll draw this triangle first. Okay. So let the triangle be drawn over here. This is A, this is B, this is C, and the foot is D over here. Okay. This point is D. Right. Now some things are given over here. Tan B is equal to 4 by 3. Okay. Tan B. So by definition, tan B is opposite upon adjacent. Opposite to B is AD and adjacent to B is BD is equal to 4 by 3. Okay. We'll cross multiply. AD is equal to 4 by 3 BD. One uh, conclusion we have got. Now I'll write the other conclusion. One more thing is there. That's one. So they have given cos C is equal to 15 by 17. Okay. So cos C adjacent, that is DC. I'm considering this triangle ADC. Okay. Yeah. And earlier for B, tan B, I considered ABD triangle. ABD. Fine. So don't get confused. So cos C, adjacent to C is DC upon hypo. Hypo is AC. Okay. So this is also one relation that we have got. We can just write DC is equal to 15 by 17 AC. Okay. The two things we have got over here, right? So make use of all these things. And one more thing is given, that is AB is 20. AB is 20 over here. So I have just made a note of it. Okay. Now see, in triangle ABD triangle, AB square plus BD square is equal to AD square. Okay. AB square is equal to BD square plus AD square. Sorry, by Pythagoras theorem. In triangle ABD, AB square is equal to BD square plus AD square. BD square plus AD square. So AB square is 20. So 20 square. BD value. Let us see. Do we know BD value? Okay. And AD value. AD is equal to 4 times BD. So I'll keep BD as it is. Okay. And AD is equal to 4 by 3 BD. I'm replacing AD with 4 by 3 BD. So this is BD square plus 16 upon 9 BD square. Okay. Take LCM. 9 plus 16, that is 25 BD square. Okay. Upon 9. So when you calculate this, BD square is equal to 400 into 9 upon 25. Okay. So that you can calculate. Just a second. 400 into 9 divided by 25. So that is just 1 second. I'm just checking some values over here. If I've done some copying error. That is 144. Okay. Yeah. So BD is equal to 12. The length cannot be negative. So we've just taken 12 over here. Okay. We got the value of BD. Now we know one thing for sure. AD is equal to 4 by 3 BD. AD is equal to 4 by 3 BD. 4 by 3 into 12. 3 ones are 3 4. So AD is equal to 16 centimeters. Okay. Right. So we got the value of AD. AD, BD, we got those values. Okay. Now see, let's go back to this triangle. AD, this particular triangle, ADC, in triangle ADC. Okay. AD square plus DC square is equal to AC square. Okay. AD square, DC square plus AC square. So AD value we got, na? 16 square. Okay. Now we have one more relation over here. DC is equal to 15 by 17 AC. So DC is equal to 15 by 17 AC. Okay. 256. 225 AC square upon 289 plus AC square. I think I made some error over here. Sorry, this should be plus. Very sorry for this. Okay. I have to go back again and again. So these errors do occur at times. Okay. 1 second. This will be equal. Yeah. So 256 is equal to AC square minus 225 AC square upon 289. Take LCM. 289 AC square minus 225 AC square. I'll write directly after taking LCM. So that is 64. 64 AC square upon 289. AC square is equal to 256 into 289 upon 64. That is equal to your AC square. So AC will be 16 into 17 by 4. 8. Sorry. Okay. So 8 ones are 8 to the, we got the value of AC as 34. Right? So we are getting all the sides, see one by one. Now DC is equal to 15 by 17 AC. DC is equal to 15 by 17 AC. So 15 by 17 into 34. So that is equal to 30 centimeters. Put the units and all on your own. Okay. So that was the value of AC and DC. Okay. But then they are asking BC, this particular line, total length of this particular line segment. So BC is equal to BD plus DC. BD we have calculated the value of BD. I'll show you. BD is 12. Okay. And DC is 30. So I'll just write 12 and 30 over here. Okay. So the total length of BC is 42. Fine. One more thing they are asking, value of sine A. Okay. Now we'll put all values over here first of all. AC. AC is 34. AC is 34 and AD. AD is 16. So I'm putting all the values over here, okay, in the triangle. This is 16. Now in triangle, they are asking sine A. But then when they are saying sine A, we have to consider the entire triangle ABC. We cannot consider any one of the triangles, so smaller triangles. Okay, we have to consider the entire triangle. So in triangle ABC, in triangle ABD, sine A. Okay, so we are considering this triangle. Sine A is opposite upon hypo. So that is 12 upon 20. So we'll write it's A1. Okay. Okay. So this shorter triangle, small triangle, that A I will take it as A1. This is A1 and this is A2. So sine A1 is equal to opposite to A1 is 12 and hypo is 20. In triangle ADC, sine A2. What is sine A2? Okay, so basically if I just reduce this, okay. So this will be 4 3s are 4 5s are. In triangle ADC, sine A2, A2 will be opposite, that is 30 upon hypo, that is 34. So this is 30 upon 34, 15 by 70. Okay. I'll also calculate cos for both the terms from the triangle itself. So cos value will be for A1, it will be 16 upon 20. Okay, 16 upon 20, that is 4 by 5. And cos A2. Cos A2 is, look at the other triangle where A2 is there. Adjacent to A2 is 16, 16 upon 34. 34 is the hypo. 16 upon 34. Okay. 8 upon 17. So now they're asking sine A. See how to calculate sine A. Okay. Sine A is equal to, now A total will be A1 plus A2. Okay. Now we can use compound angle formula over here. Sin A plus B. Sin A cos B. B is A2 plus cos A sin B. B is A2, sorry. We have all the four values now. 1, 2, 3, and 4. All the four values we have calculated. See, you can put these values and get the answer of sin A. I hope you all have understood this. Fine. Okay, so that was a very big problem. Question number 17. We completed it right now. Okay. Now I'll be taking you to question number 22. Fine. Question number 22 right now. Okay. Left hand side 4 sine pi by 3 minus theta into sine pi by 3 plus theta. Okay. Many ways to solve this. Okay. So RHS is 3 minus 4 sine square theta. Okay. So I'll start with the LHS, but then I'll first calculate sine pi by 3. Pi by 3 is 60 degrees converted into radians. Sorry, radians, then converted into degrees. That is equal to sine 60 cos theta minus cos 60 sine theta. So that is equal to sine 60 is root 3 by 2 cos theta minus half sine theta. Okay. Now sine 60 plus theta. Well, 60 plus theta because pi by 3 is 60 plus theta. Okay. So the answer will remain the same. Just that there is a plus sign in between. Okay. If you know the formula, you'll not get confused. Okay. Otherwise, just calculate and verify. So we got both the values. Now we have to multiply these two values. Okay. So I'll go to the next page. I'll start with LHS 4 into the first value that we got was, see, root 3 by 2 cos theta minus 1 by 2 sin theta. And the other value is root 3 by 2 cos theta plus 1 by 2 sin theta. So 4 into root 3 by 2 cos theta the whole square minus sin half sin theta the whole square. I did a minus b into a plus b. A minus b into a plus b. Okay. Yeah, a square minus b square. So 4 3 by 4 cos square theta minus sin square theta by 4. So when you take the LCM in the box bracket, that 4 and the 4 which is outside will get cancelled. Now our final answer, RHS, is in terms of sin square theta. So what I would recommend is this cos square theta is 1 minus sin square theta. Okay, minus sin square theta. Open the bracket, 3 minus 3 sin square theta minus sin square theta. Now 3 sin square theta minus sin square theta is 4 sin square theta. So 3 minus 4 sin square theta. This is equal to your RHS. Okay. Yeah. Fine. So that was question number 22 for you all. Right. So let us go to question number 26. Yeah. So what we are supposed to do is we are supposed to prove cos 2 theta cos 2 phi plus sine square theta minus phi minus sine square theta plus phi equal to cos theta plus 2 phi. Okay, so we'll start with the LHS, but then while calculating the LHS, I'll just calculate these terms individually. So first I'll calculate sine theta minus phi, that is sine theta cos phi minus cos theta sine phi. I'll make this theta, sorry. Okay, but then there is a square. So you'll have to square this. So this will be sine square theta cos square phi. I'm applying a minus b the whole square plus a square plus b square minus 2ab. So sine theta cos theta, this is a and this is b. Yeah? This entire term is a and this is b. Sine phi cos phi. Okay. So this is sine square theta minus phi. Okay. Now if it is sine square theta plus phi, we'll not do it separately. We'll just write it over here. If it is plus over here, then there will be plus over here and there will be plus over here. Okay. So both the values we have calculated. We have calculated sine square theta plus 5 and sine square theta minus 5. The only difference is the plus sign. You can check it for yourself. So let's add these two terms. So if we add term 1 and term 2, the answers of term 1 and term 2, okay? So it will be sine square theta cos square phi plus cos square theta sine square phi minus 2 sine theta cos theta sine phi cos phi plus sine square theta cos square phi. I think it's minus in between. Sorry. Let me just check this. It's minus in between. Okay. Sorry. So we have to just subtract, not add. Okay. Let's put a bracket over here. Cos square theta sine phi plus 2 sine theta cos theta sine phi cos phi. Okay. So when you open these brackets, this and this will get cancelled. This and this will get cancelled. Minus and this plus is minus. So minus 2 and this minus 2 will become minus 4 sine theta cos theta sine phi cos phi. So take minus sign outside and see how I'm writing now. 2 sine theta cos theta 2 sine phi cos phi. So this is half angle formula, which is in exercise number 3. 2 sine theta cos theta is sine 2 theta and 2 sine phi cos phi is cos 2 phi. Okay, and we get the answer as negative over here. Fine. Yeah. So now this particular part, this part, I'm going to put it over here, wherever I have encircled, and there is a plus sign. So our LHS will be cos 2 theta cos 2 phi minus, because the circled part I have got over here, it's negative, minus sine 2 theta cos 2 phi. Sine 2 phi. Oh, sorry, I just applied the wrong formula. Uh, 2 sine phi cos phi is sine 2 phi. It's a half angle formula. So I'll just put this value minus sine 2 theta sine 2 phi minus sine 2 theta sine 2 phi. So cos A cos B minus sin A sin B. That is cos A cos B minus sin A sin B. That's cos A minus B. Cos A plus B, sorry, because negative will become positive in cos. So this will be cos 2 theta plus 2 phi. And this is your RHS. You can verify this. Okay. You can scroll back and check, like if you're getting confused anywhere, you get the right answers. Okay. Or your confusion will be clear. Right. So I think we are left with only question number 15 that we will do it right now. Okay. So guys, let us go to question number 15. Okay. A and B are acute angles. Find A plus B. First part. Sine A is 1 by root 5 and sine B is 1 by root 10. We need to find out A plus B. Now A and B are acute angles. Both are lying in the first quadrant. Okay. So sine A. So A is over here, opposite upon hypotenuse. So by Pythagoras theorem, if you calculate, this will be 2. Okay. And here sine B, opposite upon hypotenuse. So by Pythagoras theorem, if you calculate the adjacent side, it will be 3. Okay. So cos A, the value of cos A is 2 by root 5. That is also in the first quadrant. And cos B is equal to 3 by root 10. First quadrant, so both are positive. Okay. And for the safer side, I'll just calculate tan A and tan B as well. So tan A is equal to half and tan B is equal to 1 by 3. Okay. So now see, let's calculate tan A plus B. You can also go ahead with sin A plus B or cos A plus B. Okay. Yeah. I'm preferring tan A plus B. So tan A plus tan B, 1 minus tan A tan B. Okay. Yeah. So what is tan A? Tan A is, we calculated the value, half, and tan B is 1 by 3. So half plus 1 by 3, 1 minus half into 1 by 3. So 3 plus 2 upon 6, and this is 6 minus 1 upon 6. So this is 1. Tan A plus B is equal to 1. Okay. So A plus B is equal to 45 degrees. Okay. Or maybe we should say 5 by 4 radians. We got to put the value of A plus B. Okay. Let's go to the next sub question. That is sub question 2. Already you know the value of tan A and tan B. So you can just calculate, use this formula and get the value of A plus B. Okay. Right. That was question number 15. Sub question 1 and sub question 2. Yeah. So I think this particular exercise is totally covered up. Fine. Okay. I think one problem is left. That is question number 18. We'll proceed with that right now. Fine. I think that is the only one left in session number 2. Otherwise, each and everything we have covered in this particular session as well as the previous session which I recorded. So question number 18. Tan A plus B is equal to 1. Okay. So that is equal to tan A plus tan B upon 1 minus tan A tan B. That is equal to 1. Fine. So I'll do one thing for the simplicity. I'll take tan x as x, tan A as x, and tan B as y. Okay, 1 minus x into y, which is equal to 1. Therefore, x plus y is equal to 1 minus xy, and this is equation number 1. Okay. So next step, tan A minus B. Now tan A minus B they have given as 1 by 7. So tan A minus tan B, 1 plus tan A tan B this time is equal to 1 by 7. Okay, so x minus y, 1 plus xy is equal to 1 by 7. So 7x, I'm taking tan A as x and tan B as y. Okay, equation number 2. Right, so this is what I've got. I'll subtract equation number 1 from equation number 2. So this will be x plus y, 1 minus xy. One second, I'll just take a look at equation number 1 once again. Okay, so this is equation number 1. I'm adding 2 and 1 because that xy and xy will get cancelled. Okay, so just add this. Okay, so this is gone. This is equal to 2. 7x plus x is 6x minus 6y is equal to 2. Okay, we got 6x minus 6y is equal to 2. So 3x minus 3y is equal to 1. I divided throughout by 2. So what is 3x? 3x is equal to 1 plus 3y. Okay, so what I will do is I'll get the value of x from here is equal to 1 plus 3y upon 3. Now put this in any one of the equations. Put this x in equation number 1, let's see. So what is equation number 1? X plus y is equal to 1 minus xy. So put the value of, I think, let's put the value of x. Okay, that is 1 plus 3y upon 3. So this is 1 plus 3y upon 3 plus y is equal to 1 minus x. X is 1 plus 3y upon 3 into y. So x plus 3y plus 3y upon 3 is equal to 1 minus y into 1. I'm taking that y inside the bracket first, and then I take LCM. 3y plus 3y is 6y. 3 minus y minus 3y square upon 3. Okay, and this 3 and 3 will get cancelled. Now shift all the terms on the right hand side to the left hand side. So it will be 3y square minus y plus 6y, that is 7y, and 1 minus 3, that is minus 2. So 3y square plus 7y minus 2 is equal to 0. So the multiplication is minus 6, 3 into minus 2 minus 6. So addition should give you 7. So 6 and 1. Okay, right? Okay, I think something has gone wrong. Just a second. Let me just cross verify. 1 plus 3y upon 3 and 1 minus 1 plus 3y upon 3. Y plus 3y square upon 3. So 3y square plus 7y minus 2. Just a second. I'm just stuck over here. So I have got my mistake basically. I just made some calculation error over here. So 7x plus x, that is 8x. Okay, excuse me for this. Yeah. So this entire side goes wrong because I just deleted this and write everything once again. So x plus y is equal to 1 minus xy. We are putting the value of x in this particular equation. Okay. And here also there will be some changes. Okay, so I'll just change this also. Sorry. Sorry to waste your time. Okay. 8x minus 6y is equal to 2. So 4x minus 3y is equal to 1. Divide through by 2. So 4x is equal to 1 plus 3y. So x is equal to 1 plus 3y upon 4. Let's put this in equation number 1. So 1 says this is what is 1. I'm putting the value of x. X value is 1 plus 3y upon 4. 1 plus 3y upon 4. So 1 plus 3y plus 4y upon 4. Let's hope this is the right calculation because there were some errors earlier. I'm taking LCM and I'm opening this bracket also. Minus y minus 3y square upon 4. 4 and 4 will get cancelled. Okay. So simplify this further. 1 plus 7y is equal to 4 minus y minus 3y square. So 3y square, okay, plus y. 7y plus y, that is 8y. Okay, fine. And 1 minus 4, that is minus 3. So 3 into minus 3, that is minus 9. So that is 9 into 1 plus into minus. Okay, 3y square plus 8y plus 1 minus 4, that is minus 3. Okay. So we got the product as minus 9. And since there is plus over here, plus 8y, I'm taking 9 as positive, 1 as negative. So 3y square plus 9y minus 1y minus 3 is equal to 0. 3y, y plus 3 minus 1. So 3 minus y plus 3 is equal to 0. Y is equal to 1 by 3. Y is equal to minus 3. So tan B can be 1 by 3 or tan B can be minus 3. Okay. Now put this, we know x is equal to, let's say, 1 plus 3y upon 4. 1 plus 3y upon 4. So case 1, there will be two cases after this. Case 1, put y as 1 by 3. You get a value of x, that will be tan A. Case 2, put the value of y as minus 3. Okay. Whatever x value you get, that will be the value of tan A. Okay. X value is tan A. So you'll get two different values of x and both the values will be tan A. So solve case wise after this. The solution will be over. Okay. So that is the end of this particular exercise. Okay. Thanks guys. Bye.